on the back of your worksheet, okay, it says multiplying and dividing fractions on the front. There are 15 problems. I want you to turn it to the back. What do you see on the back? Nothing. Nothing. Okay, we are going to take notes on the back to refresh our memories on how to multiply and divide fractions. But I'm missing all my things. There they are. Okay, so at the top, let's write multiply. Who can tell me why is multiplying easier than adding and subtracting? Maya? Yeah, what do we not need? Yeah, we do not need a common denominator. So multiplying, in my opinion, is the easiest fraction operation. Because all we have to do is what? Multiply straight across. Multiply straight across on top and bottom. Multiply straight across on top and bottom. Since my answer is a fraction, what do I always have to do after that? Haley? What should I always try and do after? Simplify. Remember, sometimes we can simplify before we multiply. How can I simplify before we multiply? I'm going to make a side note. So just draw a little star. And let's write sometimes you can simplify before multiplying by what? Brant, do you remember? What do you mean dividing them out?
If it's an even number, then you can make it smaller so it's easier to multiply maybe?
Okay, so you can actually reduce the fraction, each individual fraction. You're right. So let's put a colon here because you're right, that works too. So you could reduce each fraction if they're reducible. So for example, if it says like 6/12 times 2/3, you could reduce 6/12 to what? 1/2. And do 1/2 times 2/3. He is correct there. So you could reduce each fraction. Let's just show an example of that. We'll do the one I just said. 6/12 times 2/3 could turn into 1/2 times 2/3. Anybody see something else I could do on that problem? Maya? Yeah, so sometimes you can reduce each individual fraction, and sometimes you can, I'm going to write cross cancel / reduce. What does that mean, to cross cancel or cross reduce? Parker, what does that mean? Yes.
Something across from it or diagonal from it, the number goes into even side.
I agree with part of what he said. Okay, he said if there's a number across from it or diagonal from it, you can reduce it or see if something goes into it. I agree with part of that is true. Where do the numbers have to be located? Harper? Yeah, they have to be diagonal, okay? It's called cross-canceling and reducing. Maybe in parentheses, right, they must be diagonal from each other. So on 1/2 times 2/3, do we see anything that would cross cancel or cross reduce? What, Kendall?
6 and 3.
Okay, 6 and 3. Oh wait, hold on, we're looking at the new one, sorry. We're looking right here. Up at the top, you're right, 6 and 3 could cross reduce. Abby?
2 and 2.
2 and 2. If they are the same number, you can just cross them out. Because what would you divide them both by? By 2, by that number, okay? What's 2 divided by 2?
1.
1. If I multiply something by 1, is it going to change its value? No. So if it's the same number, you don't even have to show divide by 2 equals 1 equals 1. You can just cancel it out. Now, what's the only number we have left on top, Maya? 1. What's the only number we have left on bottom? 3. Oftentimes, cross-canceling and cross-reducing makes the problem 10 times easier. We're going to work that same problem just by multiplying straight across and then see how that makes it easier. So what is 6 times 2? 12. Let's show this work up here. What's 12 times 3? 36. Can 12 over 36 be reduced? Bryson, what goes into 12 and 36?
12.
12. Okay. Could we have divided them both by 2? Could we have divided them both by 3? Could we have divided them both by 6?
Yes.
Yes. We could have done 4 would have worked. But Bryson picked the biggest number that goes into both of them, which is good. That means we'll only have to reduce once. What is 12 divided by 12?
1.
What is 36 divided by 12?
3.
3. Did we get the same answer? Yes, okay? It's just oftentimes if we reduce sooner, if we cross-cancel, cross-reduce at the beginning, we have smaller numbers to multiply, okay? Lower numbers to do math with. Okay, so now we're just going to do several examples. Nate, give me a fraction.
6/12.
Besides 6/12, because we just used that one.
8/12.
Okay. 8/12 times 4/5. We have some options here. Dane, what's one thing you see that I could do before I multiply straight across?
You could cross cancel the 12 and 4.
Okay. Do you guys see how there's a 4 and a 12 diagonal from each other? Could those be reduced? Okay, we're going to work this one 2 different times. Harper, is that the same thing you noticed? Okay. So I want you to draw an arrow this way from that problem and draw one that way. We're going to work this one twice. When you're working on your homework or anytime you're doing multiplying fractions, I don't care how you get the fraction reduced in the end, as long as you finish it, which means reduce it at some point. So Dane, the first time, and I'm going to rewrite it just because we're working it twice and I'm going to have to show some work. Okay, Dane notices that 4 and 12 are diagonal from each other. Dane, what goes into 4 and 12? 4, okay? So I'm going to show divide by 4, divide by 4. Then we cancel that out and show what it is. What's 4 divided by 4? 1. What's 12 divided by 4? 3. Now, do I have smaller numbers to divide or to multiply out?
Yes.
Sadie, what's 8 times 1? 8. And 3 times 5? 15. Can 8 over 15 be reduced? No. Sometimes if you cross-cancel, if you reduce a fraction, once you multiply, sometimes you still have a fraction that can be reduced. So always check your answer and see if you can reduce it down any further. Okay, let's stop there. I'm going to rewrite the problem over here. I told you we're working this one twice. Does anybody see something else I could have done from the beginning? Lori?
You can simplify 8/12.
Yeah, can 8 over 12 be reduced? Yes. What goes into 8 and 12? 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. So on this one, I saw that, hey, this individual fraction can be reduced. So I reduced it down to 2/3 times 4/5. Look diagonal. Can anything be reduced? Nope. Multiply straight across. Dom, what's 4 times 2?
8.
What's 3 times 5?
15.
15. Did we get the same answer? Yes. Do I care how you get there? No, as long as you can get there. Let's do one more. Eight ninths times 4/3. Look diagonal. Can I reduce anything? Multiply straight across. Brady, what's 8 times 4?
32.
32. Bryce, what's 9 times 3? 27. Is there anything that goes into 32 and 27? 2 doesn't because they're not both even. Does 3 go into 32? 4? 4 goes into 32. Does it go into 27? 5? 6? 7? 8? 9? 10? No. Okay, so am I finished? Why not? Why do I have to divide this one out, Reese? Because it is an improper fraction, so we're going to have to go out to the side. Do a little bit of work. Nate, how many times does 27 go into 32? Once, so I put a 1. I subtract and I get 5. What is my answer? Reese?
1 and 5.
Yeah, my remainder becomes my numerator. My denominator stays the same. And remember, sometimes when we get a mixed number like that, the fraction can still be reduced. So always double check that. Okay, good on multiply? Okay, let's move on to divide. Notice on multiply, did we flip anything? Did we change anything? No, we just reduced. Dividing. Who remembers my rule? It's not 3 letters. That is my trick. I'm not asking for the trick. I'm asking for the rule. Dane? Multiply by the reciprocal is the rule. So to divide fractions, we multiply by the reciprocal. You guys all know what multiply means. What is a reciprocal? Brady?
A fraction that's so it's like a fraction flip.
Yeah, it's when you flip a fraction. So what is the reciprocal of 2/3?
3 halves.
3 halves, good job. What is the reciprocal of 2?
1 half.
1 half, good job. Because 2 is 2 over 1, so the reciprocal you would have to flip it. What is the reciprocal of 1/3? 3. Just 3, or 3 over 1. Yep. Okay, so multiply by the reciprocal is our rule, which those words are kind of confusing. What is the trick that I taught you to help you remember the rule? Haley? KFC. Let's write this one more time. KFC. Now, is KFC for multiplying fractions? No. What I have noticed is once I taught you guys how to divide fractions, you were going flip crazy and flipping fractions all over the place. The only time you use KFC is if you have a dividing fractions math problem. And it's because we do not divide fractions, we multiply by the reciprocal. What does that K stand for, Abby?
Keep.
Okay, keep, can you elaborate on that? Keep what?
Keep the first fraction.
Yep, keep the first fraction, 2 more words. The same. Keep the first fraction the same. That means we're not changing it at all. We're just dropping it down to step 2. Bryson, F.
Flip the second.
Flip the second fraction. Okay, flip the second fraction. That's our reciprocal. Parker?
Change the divide to multiply.
Yeah, change the divide sign to, I'm going to go ahead and put the X. I like the dot better, but it looked like you just had a random dot on your paper. Once we KFC, then what do we have to do? Maya, you follow your multiplication rules, okay? So after that, you follow multiplication rules. I'm going to do a couple examples, and then you'll have some time to work on your homework. Okay? Move this up a little bit. I think those of you still writing have most of it. Nate, not Nate. Nate gave me one last time. Dominic, give me a fraction. 9/20. Divided by Max, give me a fraction. 3/5. Okay, I see a dividing fractions problem, and in my head I should be thinking we don't divide, we do what, Brant? What is my rule? We multiply by the reciprocal. What does that mean? What is my trick, Bryce? Okay, so explain, elaborate on that. What's that mean?
Keep the first fraction.
So I'm going to keep the first fraction the same. Okay?
Flip the second fraction.
Flip the second fraction.
Change the divide sign to multiply.
Change the sign to multiplication. Now we follow multiplication rules. Our multiplication rule says multiply straight across, but sometimes see if you can reduce early. Is there anything I can reduce before I multiply? Kendall?
9 and 3.
Okay, if I look diagonally, I see a 9 and a 3. Kendall, what goes into 9 and 3? 3. So I'm going to divide both of these by 3. I'm just cross-reducing here. What is 9 divided by 3? 3. 3 divided by 3 is 1. Parker.
That means multiply 5 by 20, 5 and 20.
So I can reduce the 5 and the 20 the other way. So sometimes you can cross-reduce both directions. Parker, what goes into 5 and 20? 5. So I'm going to reduce both of those by 5. Let's show that work. So that is 1. 5 divided by 5 is 1. 20 divided by 5 is 4. How did that make our problem a lot easier? Yeah, the numbers are a whole lot smaller. Okay, don't strain yourself here. Abby, what is 3 times 1? 3. Bryce, what is 4 times 1? 4. So our answer is just 3/4. 3/4. Now, just to show you that the order matters, the order matters in division, we are going to divide it the other way. 3/5 divided by 9/20 is going to be our second example, because a lot of times when you guys are working these, you flip the numbers. And I want you to see what your answer will look like if you flip the fractions. I see a division problem. Lori, what is my rule?
We need to keep the first fraction the
So that's my trick. What is my rule?
multiply by the reciprocal.
Multiply by the reciprocal. Okay, now go on with my trick. What does that mean? What do I have to do?
We need to keep the first fraction the same.
Okay, keep the first fraction the same. Good job. Keep going.
We need to change the order of the second fraction.
So flip the second fraction.
And change the divide sign to a multiplication.
Change the sign to multiplication. Now I have a multiplication problem. Can we still cross-reduce the same as we did before?
Yes.
Okay, let's pretend we don't notice that.
Oh, man.
Let's pretend we don't notice it and we like to make our life a little bit harder. It's fine. We'll still get there. It'll just take us longer. Multiply straight across. Max, what's 3 times 20? 60. Haley, what's 9 times 5? 45. Can 60 over 45 be reduced? Sadie, what goes into 60 and 45? 5. So let's show. We're going to divide them both by 5 because we're reducing. The bottom one's easy. How many times does 5 go into 60? 12. We get 12 ninths. Can that be reduced? Sadie? Divided by 3. And Parker said we could have divided the beginning by 15. Brady, if we divide by 5 and divide by 3, what's 3 times 5? 15. So he is correct. It's okay though, as long as we get there. I don't care how you get there. Jude, 4/3. Is that simplified? Why not? What else do I have to do? Yeah, it's an improper fraction, so I have to flip it around, divide it out. How many times is 3 going to 4? I have 1 left over. So final answer, 1 and 1/3. Now, those numbers don't look much alike, but look at our last step before we finished it. How do those two answers compare? Harper? They're reciprocals. Does anybody know why? Yeah, let me rewrite these problems in a different way. I'm going to write them as a complex fraction. No, you don't have to write this. That's called a complex fraction. All it is a division problem. It's a fraction. The big division bar is considered the divide sign, and the bottom one is a fraction. So all I did is I flipped the fractions from top to bottom. So I took the reciprocal of the problem, so my answers are reciprocals. That's going to be a common error sometimes, is if I tell you that the answer's 2/3 and you got 3/2, 1 1/2, that means you had your order wrong in the problem a lot of times. Okay? So tonight we are practicing multiplying and dividing fractions. If you KFC on a multiplication problem, will you get it correct? No. No. If you divide straight across on a division problem, will you get it correct? No. Where did we put the rules? On the back of your worksheet. So if you need to flip back and forth to double check and make sure you're doing it correctly, then flip back and forth to make sure you're doing it correctly. Okay, your homework is the front side. It is all 15 problems, but you have about 15 minutes of class time to get started on it. Okay, and I think some of you will even finish it in that time.